All right, good afternoon. Let's take a look at the triangle trig stuff, find an area. What we want to do here is basically take a look at these regular polygons and break them into triangles. So the biggest thing we're going to know today is that the area of a triangle is going to equal our 1/2 base times height. Okay, there's the other formula in the book, which you're more than welcome to use, which is saying that the area of a polygon is going to equal 1/2 the apothem times the perimeter. And by all means, feel free to use that formula if that makes the most sense to you. But for me, I like doing the triangles because that's what we've done forever. And then once I have the triangle, I know they're all congruent, and I can multiply by the number of them. Okay? So let's take a look at a decagon. A decagon has 10 sides, and by the same notion, we can say that it also has 10 congruent triangles in it. Okay? What I like doing is just breaking down just the triangle part. And so we're going to take a look at what this triangle is going to look like. And so if I look at my 10-sided figure, which I'm going to draw a terrible version of it here, but assume that's our 10-sided figure, and we've got 10 of these triangles, and I'm not even sure if I drew 10 or not. Okay, we got 10 of these triangles. I want to figure out what the angle of one of those tops is. Well, as I go around in a circle, I know that there's a total of 360 degrees. And I know that I have 10 of those triangles. So each one of these triangles is going to have an angle of 36 degrees up top. Okay? Well, to find the area of this triangle, I need to know what this height is. And so to find the height, what I want to do is split this into a right triangle. So what I'm going to do now is only look at half of this triangle, essentially. And so we're going to split this into a right triangle. I knew that entire angle up here was 36, so if I cut this in half, we know that this angle in here is 18. Okay. I have a right triangle, so I'm allowed to use my SOHCAHTOA stuff. In this particular case, because they give me a side length of 4, I know this is a side length of 4. When I cut that in half, this will give me 2. And now my unknown that I'm trying to find is my height. And so as we do this, we'll be able to recognize I have this angle, I have the opposite side length, and the adjacent side length is my unknown I'm trying to find. So we can set up a tangent equation of tangent of 18 will equal my opposite over my adjacent. We'll multiply by our denominator. And then to get our unknown completely by itself, we'll divide by that tangent. So h is going to equal 2 divided by the tan of 18. Okay, so you can type this into your calculator. Make sure you're in degree mode since we're using degrees. And we'll see that our h is approximately 6.155. Okay. Now I have my area formula for triangles. So I know my area of this triangle is going to equal 1/2 our base, which our base we knew was 4, that was given to us from the beginning, times our height, which we just found as 6.155. And when we type this into our calculator, we'll see that this tells us we have an area of the triangle of 12.31. Okay? Well, that's for one triangle. So if I want all 10 of these triangles, I'm going to have to take this number and multiply it by the 10 triangles I have. Okay? And so now my area of the actual polygon is going to equal 123.1 units squared. Okay, so that's the way I'm going to try to suggest you guys to go, is using this breaking things into triangles. It'll help us solve any and all shapes basically for area, because you can break things up into the triangles. So that's the route I'm going to go. But you could also, once you found the apothem, which is the height, we could type that in, and then we find the area or the perimeter, which would have been 10 times 4, which is 40. So 40 times this height here, and then we're going to cut that in half. So essentially it's the exact same formula, just we multiplied by 10 at this step instead of multiplying by 10 to find the perimeter at that step. It's the exact same formula. Okay, so let's take a look at another option. Okay, so move all of this out of the way. Okay, so another option we've got is something where we've got a 20-sided figure, but this time instead of giving us a side length, the information it's giving us is a radius. So let's have that conversation real quick about what that even looks like. So we've got this 20-sided figure, and 20-sided figure starts to look kind of like a circle. Anyways, but instead of having, hold up, let's do a different route. Let's look at a zoomed in version. So let's say here is kind of a zoomed in version. Our height of this triangle we've been looking at was last time. The radius is this piece here. Okay, so from the center to a vertex, these are the actual radiuses. So when I go to build this triangle now, the information I have is not the base and it's not the height. The information we're going to be given is this piece on the outside. So I have a radius of 2. Okay, we're going to use the exact same process of taking our 360 and we'll divide by, now I have 20 sides and a 20 gone. So each of these bigger angles is going to be 18 degrees. I'm going to cut that in half so I can build my right triangle. So I know this angle inside is going to be 9 degrees. Okay, and now my unknown value is going to be this half of my base, so to speak, we'll call x, and then the height of our triangle. And so as we work through this one, what we'll see is I want to use the different trig functions. So I have the hypotenuse, so to find my height, let's do the cosine because I have adjacent over hypotenuse. Cosine of 9 is going to equal 2 over our height. Oops, just kidding, I screwed that up. Adjacent over hypotenuse. So actually in this case it is h over 2. Okay. We'll multiply both sides by 2, so 2 times the cosine of 9 is going to equal our height, which is approximately, I'll check my notes, 1.975. Okay, and then now we have the height, so I want to go find the x value. So for our x value, that's our opposite, so we can use the sine value. So sine of 9 is going to equal our opposite, which is x over our hypotenuse. Okay, we'll multiply by 2, so 2 sine 9 equals our x, which is approximately 0.313. Okay, and so that's this value for x, and we know that this is essentially x plus x to find our actual base. Okay, and so we can say that the base is then approximately double what this x value is. So if I multiply this by 2, okay, we'll end up with 6.626. So our base is going to be this 0.626. Now, same exact situation where I'm going to be able to take that and we'll have the area of our triangle equals 1/2 our base times our height, 1.975. Okay. And then when we multiply that all together, we'll see that the area of this triangle is going to be 0.618. And then we just have to recognize that we have 20 of these triangles, so let's multiply this by 20 triangles to figure out our total area. So the area of this 20-sided polygon, regular polygon, is going to be 12.36. Okay, so that's another way to look at it from a slightly different viewpoint, because now instead of being given a side length, we're actually given the radius, and so we have to use a couple more trig steps to kind of make all of this move properly. Okay? So last thing we're going to take a look at, which I think actually is a little bit more simple, is looking at a triangle that's not a right triangle. How do I find the area of this? Well, what we want to try to do is take a look at the fact we have a base. I want to find a height. Okay, a height is always going to be perpendicular. And then I have a hypotenuse, basically, of this right triangle I just drew. And then I have an angle 40. And so I can use that information now to figure out what the height of this is going to be. So I have the opposite side length and the hypotenuse, so we're going to use sine. So the sine of 40 is going to equal our opposite over our hypotenuse. Okay. And when we multiply this out, we'll multiply both sides by 104. So h is going to be about 66.85. Now I have a height. Here's my base. Area of this triangle is going to equal 1/2 our base times our height. Which is going to give us 7,554.05 square units. Computer's starting to slow down. Anyway, so this is a couple different ways of the things we've seen. Hopefully this is going to help you at home. Shoot me an email if you got more questions. Good luck.